Hello, good day everyone. Today we are going to discuss the topic deferred annuity. So, by definition, deferred annuity is the first payment is made several periods after the beginning of the annuity. Actually, it is called deferred annuity because some payments here or amortization or annuity were just postponed, no, or moved to the other date actually. So if you postpone some payments, so there are times during such period in which you do not have that installment or amortization or annuity. And if you're going to pay that one on the other date, so there is also such period of time in which you started to pay your annuity or amortization. So just like as you can see in this figure. These are the M periods and the N also periods, where it involves two periods actually, the M and the N periods, where during the postponement or the deferment of the annuity, we have the M periods. Actually, as you can see here, there was no amortization or annuity paid, no, from the very first year, no, here, and then the borrower just started to pay the annuity or amortization during the end periods, no? As you can see it here in this right side of the figure. So from this very first year, second year, until the end year, so the borrower started to pay the annuity or amortization. So as you can observe, uh, it involves two periods because of the deferment of the payment of the annuity. Okay. Considering now these M periods here, actually we have now this designation of P given F, I percent, and M period. So actually, this was originally came from this formula, no? F is just equal now to P times the 1 plus I raised now to the N. But since we are after here to getting the value of the principal P, so we have now this P is just equal to F times the quantity 1 plus I raised now to the negative n. But our period here is m period, so therefore our n is just equal to m. So this would become equal to P is equal now to the F times 1 plus I raised now to the negative m. Okay? So this would be it, no, for this first M period actually. So we are after now on getting this value of our principal here using the M period in which our P is just equal now to the future worth F times the quantity 1 plus I raised to the negative M, in which this quantity here is just equal now to this designation actually, which is just equivalent to actually P is equal now to this F times this designation here, P given F, and then we have now the I percent, and then we have the M period. Okay, so this is just equivalent to this formula. Okay, so we have now the formula here, no, for this M period. But how about during this N periods actually? We have this annuity here started in which during the first year the borrower started to pay the annuity or amortization until the nth year. So what's the relevance of this formula to this formula, and what's the relevance also of this annuity here in during the end period to this formula also? So actually here, as you can observe, we already have, no, this formula of P equals to F times this 1 plus I raised to the negative M, in which there is also now this part of the formula here, which is 1 plus I raised to the negative M. Okay, so later, after we consider now the n periods, you can really see, no, that this formula is just being derived from this m periods, which is we have this formula, and from this n periods, which we will have the formula for this annuity with respect now to the I and the n variables. Okay, so proceeding, we have now this formula here. Okay, considering this one, so if we are going to consider at this point here, if we designate this point as point 1, so if we are going to get now the value of P here using the annuity, so actually we will have now this case number 1 actually here. Okay, we have this case number 1 in which this is what we call the word papa. Okay, so when we use this case number 1, actually P is just equal now to the annuity times this quantity here, 1 plus I raised now to, since our period is n, raised now to the n minus 1 all over 1 plus I raised now to the n times this I. Okay, so this point, no, we get now the p value of this annuity during the n period. So therefore we can say that our p is just equal now to the p1, no, the principal at this point 1 here, which is just equal now to this annuity times 1 plus I raised now to the n minus 1 all over 1 plus I raised now to the n times this I. Okay, so as you can see, this from this formula here, if we are going to relate this one to the formula here, actually this annuity times this quantity 1 plus I raised to the n minus 1 all over 1 plus I raised to the n times I is just equal now to this one. Okay, okay, this is just equal now to this annuity here, this actually this one here. Okay, this is just equal now to this one. Okay, but this is during the n periods, but how about during the m periods? As what we have discussed, no, prior to case 1, we have already now this formula of our P equals now to F times 1 plus I raised now to the negative M. Okay, in which this formula, from this formula rather, we have now this coherence, no, this from this formula, this one is actually equal now to this 1 plus I raised to the negative M here. So what's the implication of this one actually? It just simply mean that the value of your P1 here, no, this one, from this n periods, no, considering the annuity, the value of your P1 here is just equal actually. Your P1 is just actually equal now to the future worth. during this periods. Okay, this is just the simple implication of these formulas actually. The calculated P1 here is just equal now to the future amount when you are going to calculate the principal amount during these periods. Okay, so from here, since this P is just equal now to this P here from period O prime, so we can say that from this one, P is equal now to F. Our F is just equal to P1 here, okay? So this would be equal now to A times this quantity 1 plus I raised now to the n minus 1 all over 1 plus I raised now to the n times I, okay? Times this 1 plus I raised now to the negative m, okay? In which, as you can observe, we can say that this formula is just simply equal now to this formula here. So P is just equal now to this annuity times this quantity here. So also here times this 1 plus I raised to the negative m is just equal also to 1 plus I raised to the negative m here. So this is just a very basic and simple explanation of why we have this formula here. Actually, we can really understand, no, that in order to get the value of your principal amount P here at during this zero prime period, you need to calculate first now the P1 here, considering the n periods using the annuity here, and then after you get now your P1, when you consider the m periods here, so you just have to use the basic formula, no, which we have here. Our f is just equal now to p times the quantity 1 plus I raised now to the m, since our period there is m. And then if you get the value of p, so we use this p equals to f times 1 plus I raised now to the negative m. And then our calculated p1 here is just our f here, no? We use this p1 here equal now to this f here. And then we arrive to this formula of getting the value of your p, which is equal now to this annuity times the 1 plus I raised to the n minus 1 all over 1 plus I raised to the n times I times the quantity 1 plus I raised now to the negative m. Okay? So, to better understand, no, the concept and the principle of this deferred annuity, so we will proceed now to our illustrative problem number 1. Okay? On the day his grandson was born, a man deposited to a trust company a sufficient amount of money so that the boy could receive 5 annual payments of 10,000 pesos each for his college tuition fees starting with his 18th birthday. So take note of this one. 5 annual payments of 10,000 pesos and starting with his 18th birthday of his grandson. So interest rate is 12% per annum, was to be paid on all amounts on deposit, and there was also a provision that the grandson could elect to withdraw no annual payments and receive a single lump sum amount on his 25th birthday. So the grandson chose this option. A, how much did the boy receive as the single payment? So meaning, this is just a lump sum, no, on his 25th birthday. If the boy or the grandson could elect to withdraw no annual payments, no, and receive the single lump sum on his 25th birthday. So this is referring now to the single payment and how much did the grandfather deposited or deposit. Okay. So we have here a simple cash flow diagram of this problem, as you can see here. So we have now this P, in which we didn't know how much money the grandfather has deposited, no, as this principal amount during the zero period, no. So we denote the zero period here as O prime since we are considering actually M and N periods here. So basically, this would be now the simple cash flow from the zero prime period until the this one until 17th. Why until 17th? Because according to the problem that this grandson no starting to receive no this five annual payments no of 10,000 on his 18th birthday. Okay, so meaning, so if we are going to consider the 18th birthday of this grandson, so he started to receive this 10,000 pesos no on his 18th birthday. So that is why from zero prime until the 17th year, we have no annual payments here. So this just started on the 18th birthday of the grandson, in which this five annual payments here are referring now to this five 10,000 pesos each year from the 18th, 19th, 20th, 21, and the 22nd year. Okay, and why is it that we are up to 25 years? Because according to the problem, the boy also has the provision that he could elect to withdraw no annual payments and receive a single lump sum on his 25th birthday. Okay, so that is why we are until this 25 years here, because the problem said that how much the boy received as a single payment, no, referring to this lump sum here during the 25th year, and we do not know how much, and then we also do not know how much the father no this the father of this deposited from the bank. Okay, so first we have now this M periods from 0 prime until 17th year, and starting on the 17th until this 22nd year. Based on the problem is there were five annual payments, so that's why five of 10,000 pesos each from 18, 19, 20, 21, and 22nd. And during the 23 and the 24th until the 25 years, there is again no a deferment of these annual payments. So actually, these M and N periods are just minimum periods. No, actually we have another period here referring now to the deferred annuity here. Actually, we can assign this one. If this is M periods and periods, so we can assign this one as the O periods actually. So actually, we can put O periods here in this span of time, so that we can use now the formula no in calculating this X no this value of our lump sum or the single payment amount during the 25th year of this grandson. Okay, so we have here considering now the end periods. So from the 17th, since this is now our end period, so this 17th is just being considered as the zero period during this end period. So we put it here, no, zero above the 17, and we are involving here 5 years from this zero period. Since if we are going to have this five equal annual payments, so first year, second, third, fourth, and fifth until the 22nd year. So first, second, third, fourth, and fifth year considering now the end periods. That's why we have now this n here equal now to 5 years. And again, based on the problem, the interest rate is just 12%. And we are going actually no to calculate first no at this point here. At this point here, we are going to calculate the future amount since we are going no from this zero year going to the right, meaning we are going to calculate the future amount here until such time after getting this future amount, we will use this one as the an amount here, no, in getting the x value here, no. This future amount here calculated f here is just equal now to the p here in calculating the future amount, which is x, or the lump sum or single amount in during the 25 5 years. Okay, so we have now this blue color, no, which is referring now to this another deferred period, no, from the starting from this 22nd year until the 25th. So if you are going to count, no, the n years is 1, 2, 3. So our period here is just 3 years, and then still our interest rate is 12%, and our designation here is F given P. Since we are going now to calculate actually the value of our F, which is then equal now to this X, or the lump sum amount, in which our value of P here is just equal now to the calculated F here from this n periods actually. Okay, and to start with this calculation, we are going to consider now the considering the n periods. Okay, the n period. So we concentrate here, no, from this first annual payment, second, third, fourth, and fifth until the 22nd year. So we are involving here actually annuity. So since we are after now to this lump sum, no, so we are going now from left to right. So we are going to calculate then the future amount, no, of this n period, so that after calculating this one, we can proceed now to this another period, no, deferred period, with this blue color. So here we are just going to calculate the value of our f, in which in this case we are going to consider now the case number. We are considering now the case number 2. Okay, case number 2 actually. So what is this case number 2? So as what I'm saying, to remember this one is just consider the word FAFA. Okay, so from here, so we have now this FAFA. So F is equal now to A times this quantity 1 plus I raised now to the n minus 1 all over I. Okay, so this is just equal now to the word FAFA, or we just say A, and then we have now this F given A I percent n, since we are considering n period, so this is n. Okay, so from here we can actually calculate, no, F, no, the value of our F. So if we consider this point as point 1, so we'll just assign, no, with this point here as our point 1. Okay, so in calculating the future amount at this point 1, so we can actually designate this one as F1, no, at point 1. At point 1, so we can have this formula, no, for case number 2, which is F is just equal now to F1 actually, since we are considering point 1 is equal now to annuity, which is 10,000. Okay, times 1 plus our I is just 12%, 0.12, then raised now to our n is just equal now to 5 years. Okay, so 5 years minus 1, okay, all over 0.12. Okay, so our F1 is just simply equal now to about 63,528. Okay, okay, so we have now this value of our F1. Okay, So after getting this f here, so we are going to get now the value of our future worth involving this duration here, no? In which if we assign m periods, n periods, so we are going to assign maybe this one. We are going to assign this period here as, so we just have to consider this one, no? And then we are going to assign this period as our, actually we will denote this one as O period, okay? Or periods. Since M, N, and O, okay? So we have now these periods here actually. So we may indicate this one with this arrow, this period here, and this one, okay? This is our O periods. So considering now the O periods, so we will put it here considering the O periods, okay? So we have here our value of O, which is from this year, no? So 1, 2, 3. So our O here is just equal now to 3 years actually. So that's why it is 3 years, and still our interest rate is 12%. So from the formula actually we have now this F is equal now to P times the quantity 1 plus I raised now to the N. But our period here is referring to O, so this is just equal now to P times 1 plus I raised now to the O, and then which is equal now to P times 1 plus I raised now to, since our O is 3 years, so raised to the 3, okay? Okay, so as what I've said, our F1 here is just equal now to, our F1 here is just equal now to our P, okay? It's just equal now to our P here, this one, okay? So take note of this one. So substituting, so from here, F is equal now to P times 1 plus I raised now to the 3 is just equal now to, our P is just equal now to F1, which is 63,528 times our 1 plus 0.12 raised now to the third. So if you're going to calculate the value of our F here, which is equal then now to, equal now to 89,000, 89,250.00, okay? So we have now this value of our F here, which is equal now to our F here is just simply equal now to our F is just simply equal now to our X here, which is our lump sum, okay? Which is our lump sum or our single payment, okay? So we can say that X is just equal now to 89,250.00. So this would be now our answer for this problem, okay? So now if we are going to consider the formula, no, we have just discussed from our previous slide. Actually, we have now this formula, no, from the very first slide. P is just equal now to annuity times 1 plus I raised now to the n minus 1 all over 1 plus I raised now to the n times this I times the quantity 1 plus I, okay, raised now to the negative m. Actually, this is now the formula, no, as we have just discussed in getting the value of p given the two periods m and n actually. But if you are going to consider now the future amount, so this would be equal now to f is equal now to a, okay, f is equal now to a times this quantity 1 plus I raised now to the n minus 1 all over I times what would be our value here, this one. This would become equal to, since we are considering the future worth, no? So if you are going to consider the future worth is just equal to p times 1 plus I raised now to the n. But the period now we are considering is m. So we are just going to use now this 1 plus I raised now to, so we have to erase this one, no? 1 plus I, this I raised now to the m, okay? Since we are considering our future worth here. So for considering the principal amount, so this is negative m, but we are considering the f, the future worth, so this is just equal now to 1 plus I raised now to the m, okay? So proceeding, so if we are going to use this formula here, actually, okay, if we are going to use this formula here, since we are after on the lump sum, which is our future worth, so actually we can substitute, no? We can actually solve the same problem. So our f is just equal now to, our annuity is, we have 10,000, okay? And then we have now this value of our 1 plus 0.12, okay? Raised now to the n is how much? N is, so here 5 years, okay? 5 minus 1 divided by our I is 0.12, okay? Times this quantity 1 plus 0.12. So our value of m here is, our m here is, our m is just equal now to our O period actually, because we are dealing with this deferred annuity here to get the value of your x, no, which is our future amount f. So our m here is just equal now to this O periods, which is equal to 3 years. So substituting, so we have now this f is equal now to 10,000 times this 1.12 raised now to the fifth minus 1 over 0.12 times this 1.12 raised now to, our period O is just 3 years, okay? So this is 3 actually, okay? So proceeding, we have now this value of our f, no? Our f is just equal now to how much? Still 89,250, okay? So actually you can use now the formula, no? And then you have the option also to use my own approach also, that you are going to calculate first the future amount here, and then this future amount will become the present amount in calculating the future amount during this end period, of periods rather, and then you get the value of your single amount or single payment or the lump sum. Or you can opt also to use directly this formula as discussed in our first slide, where you have only to consider now what periods you are dealing with in calculating the value of your F or your P. So in this case, we are after on the lump sum amount or the F value, which is our X, and we are considering this deferred period actually of during this period of these O periods. Okay, so in this case, our O is just 3 years. So we are not dealing the M periods here, because we are only after this value of X using the annuity from this starting from this 18th year to the 22nd year, and then using this one to get the lump sum. So we are dealing the another period, which is our off periods here, which is referring now to 3 years. So we are after to this N and O periods if we are going to use now the formula, in which our M here is just simply is equal now to O periods, in which we are dealing with this period. Okay, so still you can get the same amount of your X or the single amount, which is 89,250 pesos. Okay, so proceeding, so we are going to proceed now to the second question. Okay, so we have now this second question here. So accordingly, is what is the amount deposited by the man to his grandson actually. So we need to determine here this value P, since we do not know how much he deposited for his grandson to receive an amount of 10,000 pesos starting from on his 18th birthday until the 22nd. So our arrow here will be directed from right to left. Okay, so we are going to the left. So from here we have now this value of our P during this 17th year, where considering the end periods, it is now our zero period. So we need to calculate now the value of our P here, and then after getting the value of P, we are going to calculate now the value of this P using the end periods, in which our P here will be equal now to the future amount here, in order to get this principal amount during the M periods. Okay, so we have now this blue arrow referring now to P given the value of F, in which our F here is just the calculated value of our P here during the end period. So consequently, we can get the value of our principal amount deposited by the man to his grandson during the M periods. Okay, and we will assign this point here as our point 1, and this point here as our point 2. Okay, so first we are going to consider now this end periods here with an annuity of 10,000 pesos, and with I equal now to 12% and N equals to 5 years. So we are going to consider actually we are after here in getting the value of our P. Okay, so in this case we will denote this one as our P subscript 1. Okay, since this is P1, and at this point here P2 is our principal amount. Okay, P subscript 2. So now from this one, so we are after for the P1, so we are actually using the case number, using the case number 2. Okay, So which we call this one as Papa. Okay. So we have now this formula for case number 2 in which our P is just equal now to A times this P given A I% and N periods. Okay. So this is also equal now to P equal now to annuity times this quantity here 1 plus I raised now to the N minus 1 all over 1 plus I raised now to the N times this I. Okay. Since we have these values no for our A equals to 10,000, our I is equals to 12%, and N is just equal now to 5 years. So actually we can get now the value of our P. So in this case, since we are considering 0.1, so this P is just equal now to this P subscript 1 is equal now to 10,000 times we have here 1 plus 0.12 in decimal of the 12% raised to the 5th minus 1 all over 1 plus 0.12 raised now to the 5th times this 0.12. Okay, then calculating, we have now this value of our P1 equals now to how much? 36,048 pesos. Okay, so this would be it now for our P1, considering now this end periods here. So we are done with P1, and now we are going to calculate now the value of our P at this point, no, point 2, in which this P is just equal now to this P subscript 2. Okay, so as you can observe, there was no annuity here, no installment made by the man now to his son. So we are just considering here the future worth, no, the future worth with respect now to P and to this I, which is 12%, and our N, which is just equal now to M, no, because we are considering M periods here. M is just equal now to 17 years. Okay, so actually we can really put here now this considering the M periods. Okay, so we have now this formula since we are after for the principal amount. So from this formula, F is equal now to P times 1 plus I raised now to the N. So we can get actually the value of P equals now to F times 1 plus I raised now to the negative N. So here our N is just equal now to M since we are considering the M period. So therefore this P is just equal now to F times 1 plus I raised now to the negative M. Okay, so this P now is just equal now to this P, but since we are considering point 2 here, so this P is just equal also now to P2. So therefore we can say that P2 is just equal now to F. Our F now is just simply equal now to this F is just equal now to our P1. Okay, so substituting here the value of our P1, which is 36,048 pesos, times this 1 plus 0.12 times this negative M, which is 17 years. Okay, so we can get now the value of our P2, which is equal now to 5,000 250 pesos. Okay, so this would be it now for this P, no, which is just equal now to P2, and we consider this one as our answer. Actually, no, this is just the amount deposited, no, amount deposited by the grandfather. Okay, so this is just one method actually, no, of solving this value of P, which is referring now to the amount deposited by the grandfather. And now I will show you another formula, no, which being indicated, no, from our first slide, no, from the very first slide that we have. So actually we have here this formula of P, if you can still remember that one. So our P is just equal now to annuity times this quantity 1 plus I raised now to the n minus 1 all over 1 plus I raised now to the n times this I, and then we multiply this with 1 plus I raised now to the negative m. Okay, so actually this is the first formula, no, that we have actually. Okay, so we try to use this formula here, and we still arrive, no, with the same value of our P, which is equal now to P2, equal now to 5,250. Okay, so since we have now this deferred annuity here with no installment from this during this end periods, and with an annual installment or annuity during the end period, so this is very applicable also here, no, using this formula of our P equals now to this quantity. So applying this formula from this deferred annuity, so we can say that our P, which is just equal now to P2, is equal now to our annuity is 10,000 times this quantity 1 plus I. Our I is 12%, so 1.12 raised now to the n. Okay, our n here is just simply equal now to, our n is just simply equal to this 5 years. Okay, so raised now to the fifth minus 1. Okay, and then 1.12 raised now to the fifth times this I of 0.12, and then we are going to multiply this with 1 plus I, so 1.12 raised now to the negative m, which is our m here is, this is the m period, so 0 to this 17 years. Okay, so we have now this value of our P, which is still equal now to 5,250 pesos. Okay, so you have now the option, no, of using the formula of calculating now the value of your P using this A times the quantity 1 plus I raised to the n minus 1 all over 1 plus I raised to the n times I, and then you multiply this one with 1 plus I raised now to the negative m. So actually this is just referring to the present worth. But how about, my question is, how about if you are going to find, how about if you are going to find the value of your f using this deferred annuity? So what formula you are going to use? what formula you are going to use if you are going to find the future worth or the accumulated amount. Since the from the first slide, no, we are only just given with this P, no, to calculate P considering the deferred annuity. So in case that you are going to find the accumulated amount or F, so simply this would be equal now to, you are just going to use this F equals now to A times this quantity here, 1 plus I raised now to the N minus 1 all over I, okay? And then you're going to multiply this one with 1 plus I raised now to the positive M. Okay, so just in case you're going to calculate the future amount or the accumulated amount, no? So you can actually use this formula. F is equal now to A times this quantity 1 plus I raised to the N minus 1 all over I times this quantity 1 plus I raised now to the M. Okay, so please remember this one because in our further topics, no, you can actually consider this formula, not only this formula involving the calculation of P only. Okay, so today also I am going to show you another method of solving this principal amount P here. Okay, so we have here a simple illustration, no, of this cash flow diagram. Actually, we already calculated, no, this lump sum or single payment, no, which is called the lump sum amount. This grandson received on his 25th year birthday, which is equal now to this 89,250. So by this, actually, we can use this one to actually get, no, the amount of P or this principal amount deposited by this man, no, to his grandson actually, with this formula here. P given F with our I 12% and N here is just equal now to 25 years actually. So I'll show you that we still have the same answer, no, if we are going to use this cash flow diagram. So since F is just equal now to P times 1 plus I raised now to the N, so we are after for the P here, so we can say that P is equal now to F, then 1 plus I raised now to the negative N. Okay, so P is just, our P here is just equal now to F, which is this 89,250 times 1 plus 0.12 raised now to the negative 25. Okay, so we have value of P here equal now to this 89,250 times this 0.05882. Okay, so we actually have this value of P which is equal now to of the same amount, 5,250 pesos. Okay, so this would be it, no, for this problem actually. So this is just also the amount, no, of money. This is now the amount of money deposited by the grandfather actually. Okay, so I think I've given you already, no, different techniques and methods on how to calculate, no, the required variable, especially in this case, no, the P. So I hope this will help, no, all of you in understanding better what is this deferred annuity is all about. Okay, so proceeding now for our last problem. So we have now this illustrative problem number 2. So if 10,000 is deposited each year for 9 years, how much annuity can a person get annually from the bank every year for 8 years, starting 1 year after the ninth deposit is made? Cost of money is 14%. Okay? So we have now a simple illustration, no, for this problem. So this 10,000 is deposited each year for 9 years. So we have here from this M periods, 10,000 until the, take note, ninth year. Okay, so how much annuity can a person get annually from the bank every year for 8 years starting, take note, this annuity is good for 8 years, but this it is starting 1 year after the ninth deposit. So if this would be now our ninth year here, so starting 1 year after the ninth, so this would be now here during the 10 years. Okay, so starting 1 year after the ninth deposit here, the ninth deposit, so this annuity is actually starting on the 10th year. Okay, so we have now this annuity here, good for 8 years. So if we count this one, so it is up to 8 years, no? Which is our n here is equal now to 8, and then our I is just simply equal now to 14% for both the N and M periods. Okay, so if we are going to consider the borrower side, so this would be now the cash flow diagram actually of this problem number 2. So we have now this 10,000, no, as cash flow, cash in, and during the M periods, and this would be now the cash out actually, no, considering the borrower side, no. And then we are going now to determine now the annuity, this A here. Okay, so proceeding, actually we can actually get now this annuity here using both the M and N period, since the problem didn't give us no the principal amount during this M periods, starting from this 0 year denoted by this 0 prime, and the problem also does not give us no the future amount, no, the future amount here. So the best way to solve now this problem to get this annual annuity here A, is just simply considering both periods M and N periods, no. So we are given with this 10,000 here deposits from the 0 until the ninth year, and we are also given by this unknown annuity here, no, starting on this 10th year up to this 17th year. So all we need to do is we are going now to assign, actually we are going to assign, considering M periods, we will assign a point here as our point 1, and we are going to get now the future amount, no, this F equal now to this annuity, which is given 10,000 pesos, and this 14%, and M is equals to 9 years. And after that one, we are going now to get the P, actually the present amount, no, considering this N periods, using the same interest rate of 14%, but our N is just equal now to 8 years, but with an unknown value of our annuity A. Okay, so we denote this one as our point 2 actually. Okay, so now we are going to consider the M periods. Okay, so we will start with this M periods actually. So here, considering the M periods. Okay, so we are after on the accumulated amount, no? F. So this is actually case number 2, okay? So case number 2 using case number 2, which is our FAFA actually. So we are going to calculate now the value of our future amount, okay? So we have here this F is just equal now to A with this designation F given A I%, and then our periods is M, so this is M, okay, in which this is just equal now to annuity times this quantity here 1 plus I raised now to, actually raised to the n, but our periods is M, so raised to the M minus 1 all over this I, okay. So substituting now the values, so since we are after on this point 1, so we denote this F as our F1 equal now to this annuity of 10,000 times our I is 14%, so 1.14 raised now to the M, which is 9 minus 1 all over our I, which is 0.14, okay. So our F1 then is just equal now to how much? 160,853 pesos, okay. So we are done with our future worth here considering the M periods, okay. So now we are going to consider this N periods actually. So considering the N periods, okay. So we are going to determine now the value of our P here, okay, and we are going to use now using the case number 1. So we denote this one as your papa, okay. So again, we have now this formula for case number 1, okay. So P is just equal now to annuity, and then P given annuity I%, and then our period is N, so this is N, okay, which is then equal now to annuity times this quantity here 1 plus I raised now to the N minus 1 all over 1 plus I raised now to the N times this I, okay. So calculating now, so we have now this P is equal now to this annuity, which is unknown, times this quantity 1, so we have 14%, so 1.14, okay. 1.14 raised now to the N, and it's our N is just equal now to 8 years, okay. So 8 minus 1 all over this 1.14 raised now to the 8, and then we have now this I of 0.14, okay. So calculating, we actually have now this equal to now to 4.6389 of your annuity. So P is just equal now to 4.6389 as a function of your annuity. Okay. So after this one, we are going now to, since we have now at the same point here for this point 1 and point 2, so we can actually equate now, equate equate our f1 is just equal now to our p. Okay, which is in this case we are considering point 2, so this p is just our equal also to p2. Okay, so we can say that since we are considering point 2 here, so our p here is just simply equal now to, our p is just simply equal now to p2. So that's why we are using now f1 here is just equal now to this p, which is equal now to p2. Okay, so after this one, we have now this value of 160,853 is just equal now to 4.6389 as a function of a, and then our annuity then is just simply equal now to 34,675 pesos. Okay, so we are done no with our annuity A, which is equal now to 34,675 pesos. Proceeding, we have now this next slide. Okay, actually I will present to you two alternate solution for this problem, and for our next slide we have now this alternate solution one for calculating actually the value of our annuity A. So using the equation of value actually, so we have now this m periods and this n periods, and we are going now to calculate the value of our annuity. Okay, so here in this alternate solution, we will consider the equation of value. If you can still recall from our previous topics, that when you involve equation of value, actually we are dealing with a set of obligations. Okay, so in this case we can assign here at the top of this horizontal line, considering now this horizontal line as the duration, or referring now to the periods, we can actually assign this side here on top of this horizontal line as one set of obligation. Okay, we can actually assign, and below this one, referring now to this cash deposit, we will assign this one as another set of obligation. Okay, I hope you can still recall the equation of value. So if we are going to assign this one as one set of obligation, so here we will assign this one as one set of obligation. Okay, and then below we will assign this here as another set of obligation. Okay, So actually we can consider first, no, this annuity here A as one set of obligation, and we are going after, no, to this point here. Okay, we will consider this one as point 1. So we are going to calculate now the value of our P, because we are going now from right to left. So this side is our principal or the present worth. So we are after on this P, considering this one set of obligation, and after calculating now the value of P, we will consider now this another set of obligation which is below this annuity. Okay, we are considering this another set of obligation which is referring now to the cash deposit of 10,000 pesos, no, until the 9th year. So in this one, we are going to consider, no, the value of our P until this point here. So we will assign this one as our point 2. So after getting now the principal amount at this point 2, in which we will denote this one as P2 and this one as P1, so we will equate, no, because according to this equation of value, we have to equate P1 is just equal now to P2 here, and then we can subsequently get the value of our annuity A. So first we are going now to do the one set of obligation, referring now to this annuity A. So we just consider on top of this horizontal line actually. So below this horizontal line, so we will not consider this one because this is another set of obligation. So if we are going to concentrate here on top of this horizontal x-axis, so we can see that we have now this annuity from the 10th year until the 17th year, but we don't have annuity here from this zero prime period until the 9th year. Okay, so just concentrate your mind on this, on top of this horizontal axis now, which is now referring now to the periods. Okay, so this, there was a presence of a deferred annuity here since we don't have an annuity, and then the annuity just started on the 10th year until the 17th year. So actually we can apply the formula actually of the deferred annuity. So considering the one or the first set of obligation, the one, or we call this one as the first set of obligation. Okay, so we have now this formula actually from the deferred annuity, no. So since we are going on calculating the value of our P, so we will use the formula P is equal now to PA. Okay, P given A, I%, and then we have now this N period. Okay, and then we are going now to multiply this one with 1 plus I raised now to the negative N. Okay, or simplifying this one, this is just equal now to P is equal now to this annuity times this 1 plus I. Actually, we are considering here Papa. Okay, case number 1, 1 plus I raised to the N minus 1 all over 1 plus I raised now to the N times this I, and then we are going to multiply this with 1 plus I raised now to the negative M. Okay, so here we have now this annuity A here. Okay, and this N is just referring now to this N periods here. So we have period here of 1, 2, 3, 4, 5, 6, 7, 8. So actually, our n is just simply equal now to 8. Okay, so this is now 8 years, and then for our m, which we consider the m period, so this is just until 90 years, 90 year. Okay, so we have now this value of our m, which is equal now to 9 years. So we are going to substitute no with this one. Okay, so p is just equal now to annuity times, we have now our I of 14%, so 1.14 raised now to the n. Our n is just simply equal now to this one, 8 years. So 8 minus 1 all over 1.14 raised now to the 8 times 0.14. Okay, and then we have now this 1.14 raised now to the negative m. Our m here is just until the 9th year. Okay, so we have then this value of p, which is equal now to 4.6389 as a function of your annuity times this 1.14 raised to the negative 9, or simply our p is just equal now to 1.4265 as a function of your annuity. Okay, so since we are dealing with this obligation no, at point 1, so we will denote this one as our P1 actually. Okay, so we will just write here P1. Okay, so now we are done with the one set of obligation. So we are going now to consider the another set of obligation, which is now our cash deposit. Okay, so we will have this one here, considering another set of obligation. Okay, so actually here we can use now the formula here using this from this point to point 2. So we are going to get the value of our p, in which we are going to denote this one as our p subscript 2. Okay, so again, p is just equal now to annuity times this p given a I%, and then our period here is m. Okay, and it is just simply equal now to a times this 1 plus I raised now to our n is just equal now to m, no, since this is m period, so m minus 1 all over 1 plus I raised now to the m times this I. Okay, and then we have now this. Okay, so we forgot no this we forgot to emphasize that during this another set of application from this point here going to point 2, actually we are no longer considering deferred annuity, because there was no instances of no payment of amount of money, because we are considering here the cash deposit from this point until this point 2 here. So if you can observe, no, this factor here 1 plus I raised now to the negative m is not present here because this is not a deferred annuity already, no? When we consider this another set of obligation because this cash deposit, no, is continuous from this ninth year, from this point here, going to this point 2. So as you can see, the cash deposits are continuously deposited, no, year by year. So in this one set of obligation, no, for considering this annuity above this horizontal line, no, axis. So if you can observe, we have an annuity here which is uniformly paid, no, and given to this capital A, but until this point, no, from this ninth year to this O prime, which we consider as the 0th year, as you can observe, there was already deferment of obligation, no? There was a non-payment actually of this annuity. Okay, so that is why this factor here is just only applicable for this one set of obligation on top of this horizontal line here. So when we are considering the another set of obligation here below the horizontal line, so there was no deferment of cash deposit, no, actually, because this is referring now to the cash deposit. There was no deferment or postponement rather of the cash deposit. So that is why this factor here 1 plus I raised to the negative m is not present here because this is continuously deposited from the ninth year or from this ninth year going to this 0 prime year. Okay, so we are only going to use this formula without this factor here, which is this 1 plus I raised to the negative m. So just to remind everyone that this term is referring actually, no, for such a period when there was a presence of postponement or deferment of an obligation actually. So in this case, for this another set of obligation, there was no postponement or deferment of cash deposit, so it is not present here. Okay, so calculating and proceeding with this one, we have now this P. Since we are considering point 2, so we assign this one as P2 is equal now to this annuity, which is 10,000, okay, times we have now this, our I is just simply equal now to 14%. So 1.14 raised now to the M. So our M here is 9 years, okay? So 9 minus 1 all over our 1 plus I, okay? So 1.14 raised now to the 9 times our I of 0.14, okay? So calculating, our P2 is just simply equal now to 49,464 pesos, okay? So proceeding, since we already have this P1 and P2, so we are going to equate this one actually. Okay, so equating, okay, so excuse me, we have it here, okay, so we are going to equating P1 equal now to P2, okay, so we have here P1 is 1.4265 A is just equal now to this 49,464. Okay, so we can get now the value of our A, which is just equal now to still 34,675 pesos. Okay, so we still arrive at the same value of our annuity, which is equal now to 64,000, rather 34,675 pesos. Okay, so proceeding now to our second alternate solution, we have now this illustration here, still using the equation of value. As you can observe here, actually we have now this consideration of this future or accumulated amount. So in our alternate solution number one, we are going after on the present worth or the P, also for this cash deposit. But in this alternate solution number two, we are going into this future worth F, no? So again, we will denote actually this one here as again as another one set of obligation, okay? Or we call this one the first set of obligation, okay? And below, we will have this here as our another set of obligation, okay? So it really now matters on calculating the value of our F with regards now to this annuity A, and then we are also going to calculate the future amount considering the cash deposit now as another set of obligation. So again, we are going to assign, actually we are going to assign this one here as our point 1, and again this point now considering the cash deposit as our point 2 here, okay? So considering now this point 1, considering the point 1 in the first set of obligation, no? Considering the first set of obligation, okay? So we are going actually on here, no? So if you can observe from this point here going to the right side, no, to get now the value of our, actually we will just assign this one as our F subscript 1 since we are after on the future worth, and this point here as our F subscript 2, okay? So if you can observe from this point here going to the right, so the annuity is continuous actually, no? There was no deferment of annuity here from this point to point 1, okay? So we can say that in order to get the value of our F is just simply we consider the FAFA. Actually this is case number 2. So F is just equal now to annuity, and this F slash A I% and n years, okay? So which is just equal now to annuity times, which is our case number 2, 1 plus I raised now to the n, okay? Minus 1 all over this I, okay? So substituting now in which our F is just equal now to F1, so F1 is just equal now to this annuity which is unknown times this quantity here, 1 point our I is 14%, then raised now to the n. Our n here is just simply equal now to, since we are considering here, so 8 years, okay? So raised to the 8 minus 1 all over 0.14. So we can actually have now this f1 as a function of our annuity A, which is just equal now to 13.2328 as a function of your annuity A. Okay, so I think we are done, no? With this first set of obligation, no? In which we are having now this f1 equal now to 13.2328 of your annuity. So now we are going to consider this another set of obligation, which is referring now to the cash deposit. Okay, so considering the another set of obligation, so which is now referring now to the cash deposit. So again, as you can see, we start here going now to the right. So this cash deposit from this point here until here is continuous, no? The cash deposit is continuous, but during this time, starting from the ninth year, from this time, no? Starting from this point here to this point 2 here, you can see that there was already a deferment, no? Postponement of this cash deposit, no? Since this is blank here. There was no amortization or cash deposit here. So actually we can apply here the deferred annuity in terms of your cash deposit actually. Okay, so we have now this formula for this. Okay, so we have here f, no, since we are considering f, so f is just equal now to again annuity times this 1 plus I raised now to this 1 plus I here, since we are referring this A here to this cash deposit. So 1 plus I, we are considering M periods here. So our M is here M minus 1 all over your I, and then we are going to multiply this with this factor here, since we already deferred, no, the cash deposits from this starting on the 10th year until the 17th year. So we have here this 1 plus I raised now to this n periods. Okay, so we are going now to use actually this formula. So we have also here f is just equal now to this. Actually, since we are getting this f2, so this f is just equal now to f2, which is then equal now to our A here is just simply equal now to 10,000. Okay, 10,000 times this quantity 1 plus I. Our I is still 14%. So 1.14 raised now to the M. Okay, M is just simply equal to 9. Okay, so this is 9 minus 1 all over 0.14. Okay, and then we multiply this 1 plus I, which is 1.14, and then our N is just equal now to this 8. Okay, so we have now this value of our F2 if you are going to calculate this one, which is equal now to 458,840 49 pesos. Okay? So after this one, we are going to equate, no? This F1 equal now to F2 actually. So equating, okay, so equating F1 equal now to F2. So we have here 13.2328 of A is just equal now to 458849. Okay, so we can actually get now the value of our annuity, which is equal now to 34,675 pesos. Okay, so still we arrive of the same value of our annuity A, which is still equal now to 34,675 pesos. So I hope no these techniques shared to you will serve no as your tool no in calculating different types of deferred annuity problems. And then I hope this is very clear now to everybody. And thank you. No, I think this is it for this day. And before we end, I would like to show to you my references, no, with Santa Maria Ippolito and of Mandawi Joel and Roger Caputi. And please like, share, and subscribe for more updated videos in the future regarding our subject, engineering economy. And once again, thank you very much for listening and watching, and God bless us all.